All right, today we are talking about 9.6, which is our last section in chapter 9, and it is about solving our rational equations, which means our answers are going to be solve for x problems. So what we're trying to do in this first set of problems is we're going to try and fix our fractions by multiplying both sides of our equations by our lowest common denominator. So if we look at this first problem, 4 over x plus 5 over 2 is equal to negative 11 over x. If I try to come up with my LCD for all of these fractions, okay, I go through my fractions. Well, this first one, 4 over x, I've got a factor of x, so that needs to be included in my LCD. Second fraction, I've got a denominator of 2 that I don't have included in the LCD yet, so I need to include that. And then my last fraction, negative 11 over x, I've got a denominator of x, but I already have a factor of x included in my LCD, so I don't need to repeat that. My lowest common denominator, what all three of these values would multiply into, the smallest value that all three would multiply into, would be 2 times x. Then I'm going to take that LCD value and I'm going to multiply my entire equation by that value. So I'm going to, for a second, we're going to ignore these two fractions, and I'm going to multiply 2x by my 4 over x. If it's helpful, you can put that 2x over 1. Well, if we think about what would cancel here, my x's would cancel, right? My denominator is going to go away, and then 2 over 1 times 4 over 1 is just going to give me 8 over 1, which is just 8. Okay, we're going to do the same thing. I'm going to multiply 2x over 1. I'm going to multiply that by my second fraction, and my 2's are going to cancel, right? And I'm going to multiply x times my 5 is going to be plus 5x. I'm going to do the same thing with my last fraction on the other side of the equation, 2x times negative 11 over x. My x's cancel. 2 times negative 11 gives me negative 22, and now it's a very easy solve for x problem where I subtract 8 from both sides and I get 5x is equal to negative 30. I divide both sides by 5 and we get x equals negative 6. And that's my answer. You do have to check for extraneous solutions in this section. So that means we need to plug in our answer of x equals negative 6 everywhere we see x in the equation and see if our two sides of our equation balance. So if I do that, okay, here's our work for checking for extraneous solutions. Everywhere I see x in this original problem, I'm plugging in our answer of negative 6. And I'm testing, are those two things actually going to end up equaling? 4 over negative 6 plus 5 over 2, does that actually equal 11 over negative 6? And we would have to get a common denominator for 5 over 2. I'd have to multiply the numerator and the denominator by 3. That's what gets them this 15 over 6. And then if I add negative 4 6 plus 15 6, I would end up with 11 6. And then this is really supposed to be a negative here. Negative 11 divided by negative 6 is going to end up being a positive 11 over 6, which is going to check out for us. So that is a valid solution. Okay, next problem, we've got 5x over x minus 2 times 7 plus 10 over x minus 2. Again, we're coming up with our LCD for our fractions. For this one, the only denominators that we have both have a denominator of x minus 2. So I'm going to multiply this entire fraction by this entire equation by x minus 2, or x minus 2 over 1 if that's helpful for you. If I distribute that in, x minus 2 times 5x over x minus 2, well, those x minus 2's would cancel, and it would leave me with 5x. Okay, if I do the same thing, distribute that to my 7. My 7 doesn't have a denominator other than 1, so nothing's going to cancel here, but my denominators are still just 1s, so it's really just multiplying 7 into that x minus 2, which is going to give me, for now, I'll just write it as 7 times x minus 2. And then I'm going to distribute x minus 2 into 10 over x minus 2. Okay, 10 times x minus 2. Again, I'll just leave that as, 10 over x minus 2. If I multiply that by that x minus 2 I'm distributing in, my x minus 2's are going to cancel, and it's going to leave me just with that plus 10. Okay, simplify that a little bit. We're going to get 5x is equal to 7x minus 14 plus 10. 14, negative 14 plus 10 is going to give me a negative 4. And then again, it's a solve for x problem, so I could subtract the 7x. We get negative 2x is equal to negative 4. Divide both sides by negative 2, and we're going to get x is equal to positive 2. Again, if we check for extraneous solutions, I'm going to plug in x equals 2 everywhere I see x in this problem, original problem. So that's going to be 5 times 2 divided by 2 minus 2. Is that actually equal to 7 plus 10 over 2 minus 2? And the problem we run into with this one is both of these denominators are 2 minus 2's, which means both of those fractions we end up trying to divide by a 0. And we know at this point that the one number we cannot divide by is 0. That ends up getting us some kind of undefined answer, which means we have no solution if that is the case, which is why it's important that we check for extraneous solutions in this section, because sometimes that will happen. All right, so one more of these. We need to come up with our least common denominator. Okay, I've got x plus 1 and an x squared minus 1. If I were to factor this x squared minus 1 a little bit though, that's a difference of squares. We could factor that as an x plus 1 times an x minus 1. So if I try to come up with my LCD, with this first fraction, I've got a factor of x plus 1, so that has to show up. With my second fraction, I also have a factor of x plus 1. I've already got that represented. I don't need to repeat that. But I don't yet have that factor of x minus 1. So my LCD for this equation is x plus 1 times x minus 1. So I'm going to multiply everything in this equation by x plus 1 times x minus 1. Again, if it's helpful, you can put that over 1. Okay, so if I distribute this in, okay, what's going to cancel with those first two fractions on the left? Well, my x plus 1's would cancel, and I just end up multiplying x minus 1 times 4x plus 1. Okay, on my right side of my equation, if I distribute that to this other fraction, what's going to cancel? Well, the x plus 1's and the x minus 1's. So that's just going to leave me with 12. If I distribute that into my positive 3, there is nothing in the denominator to cancel, so that's going to be a 3 times an x plus 1 times an x minus 1. Okay, which leaves us with quite a bit of simplifying to do. If I FOIL these binomials together, x times 4x is going to give me 4x squared. X times 1 is going to give me plus x. Negative 1 times 4x is going to give me negative 4x. And negative 1 times positive 1 is going to give me a negative 1. Over here, let's start by foiling the x plus 1 and the x minus 1. So x times x is going to give me x squared. X times that negative 1 is going to give me negative 1x. 1 times x is going to give me a positive 1x. Oops. And then positive 1 times negative 1 is going to give me a negative 1. Okay, if we do some more simplifying, adding like terms, x minus 4x, it's going to give me negative 3x. Negative x plus x is going to leave me, that's going to add to 0, and we're going to have x squared minus 1. Okay, nothing really left to simplify on the left-hand side right now, but I do still need to distribute in that 3 on the right, which is going to be 3x squared minus 3. Okay, combine my like terms here. 12 minus 3 is going to give me 3x squared plus 9. And now at this point, what I'm trying to do is I'm trying to, since I've got x squareds and x to the first, it's likely that we're going to have to solve this by factoring. And when we solve by factoring, I need one side of my equation to equal 0. So I'm going to move my 3x squared over and my 9 over by subtracting them. And that's going to give me 1x squared minus 3x minus 10 is going to be equal to 0. Solve this by factoring. I need two numbers that multiply to negative 10 but add to negative 3. And it's going to give me x minus 5 and x minus 2. Set both of those factors equal to 0 and solve. We get one answer of x is equal to 5. We get one answer of x is equal to 2. Okay, since I got two answers, that does mean we would have to check both solutions. If x equals 5 actually works, and if x equals negative 2. If that actually works, both of these end up being valid solutions. Here's our work for x equals 5. Here's the work for x equals negative 2. Both sides do end up balancing, so both of these are valid solutions.